when a chemical reaction happens, at some point the chemical reaction is going to stop. Okay, think about when you're in your backyard and you use a propane tank to light the barbecue. When you light the barbecue, you normally have a propane tank down in the bottom, and that propane tank, you open the little valve, and then you put a match or something in there, and then it lights, and then it keeps going, and that heat will keep being produced until what happens? Well, one bad thing that might happen is you might run out of propane. If the propane in your container runs out, your food may not be cooked yet. More likely, though, is you're done cooking your food, and what do? You turn the valve and you shut the container off so no more propane can come out. So a chemical reaction usually will just keep going until one of the reactants is completely used up, or you've stopped providing that. Okay? Now, the reaction that happens with propane is actually this reaction right here. That's the chemical formula for propane, C3H8. And what it does is it reacts with the oxygen in the air, so that's O2, and it produces CO2 and H2O. Another thing it also produces, which you don't normally include because it's not a chemical, is it obviously produces a large amount of heat. And that's the part that we really care about, is that's what we use to cook our food on. So when does this reaction stop is certainly when the propane runs out. Would you ever have a situation where the oxygen ran out? Think about, where's that oxygen coming from? Well, it's coming from the air. Okay, and in that case, if it's coming from the air, we hope that we don't run out of oxygen, because if we do, then we can't breathe anymore. So this reaction's always going to stop when either you close the valve and the propane shuts off and doesn't keep coming out, or you run out of propane. Okay, in this case, you're never ever going to run out of oxygen. Okay, and what that means is it means that in not every reaction, but in most every reaction, you're going to have a reactant that's going to run out, and that is what's called the limiting reactant. Okay, and it's called the limiting reactant because it limits how far the reaction can go. Okay, so this is called the limiting reactant. Sometimes they call it the limiting reagent as well. Same thing. Okay, I normally just call it the limiting reactant. Okay, and again, the propane is the limiting reactant in this case because that's the one that is going to determine how much heat, how much CO2 and H2O are going to be produced in this reaction. Okay, oxygen in this case is going to be what's called the excess reactant. Okay, and excess, when I think of excess, I mean extra. Okay, which means there better be enough oxygen to burn with all of that propane. Again, if not, then we've run out of oxygen and none of us can breathe. So the reactant that there's plenty of, that's going to be left over when the reaction is done, is what's called the excess reactant. Okay, now one of the things we have to think about is which one of these, the propane or the oxygen, is going to determine how much carbon dioxide or water get produced. Okay, if we think about how much oxygen's in the air, I have no idea, but there's a lot of it. Okay, there's a whole bunch of oxygen in the air. Okay, and well, what does that mean? It means that we can't use the amount of oxygen that's in the air to determine how much CO2 and H2O are going to get used up, or going to be made, sorry, not used up. How much CO2 and H2O are going to be produced. Okay, the reason that we care which one is the limiting reactant, which one is the excess reactant, is because it's the limiting reactant that determines how much product you're going to get. Okay, because all of the limiting reactant gets used up. Okay, most of the oxygen that's in the air does not get used up when you light your barbecue. Okay, if it did, then you're in your backyard having a hard time breathing because all the oxygen's getting used up. Okay, so we can't use the mass of oxygen to figure out how much CO2 and H2O is going to get produced, because most of the oxygen that's in the air around us isn't going to get used anyway. But all of that propane is going to get used, so that's what we use when we're doing stoichiometry problems. That's the one that we use to determine how much product we're going to get, is the limiting reactant. Okay? Now, how do you know if it's a limiting reactant or an excess reactant? Well, here's another one. Let's say you're at a dance club, and there's a pretty small dance club. Only 14 guys, 9 girls there. And in this case, there's a rule that a guy can only dance with one girl at a time. Okay, in this case, because you only have 9 girls, the girls are technically going to run out first, and so you're going to have 5 guys left over. So the girls in this case would be considered the limiting reactant, and the guys would be the excess reactant because 5 of them are going to be left without having someone to dance with. Okay? Now, most of the problems that we've done up until now involving stoichiometry, we can even go back and look at them, is I purposely wrote them a certain way. Notice, like, for example, in this example from number 6 from a while ago, I said 200 grams of hydrogen completely reacts with dinitrogen tetroxide. What am I telling you there? I'm telling you that N2H4 is the limiting reactant because this is the one that completely reacts with the N2O4, which means you're probably going to have some extra N2O4. So that's your excess is the N2O4, and N2H4 would be your limiting reactant. And notice that's the one that I used to figure out how much nitrogen I'm going to get. Okay. Notice on this one, how many grams of nitrogen dioxide are formed when 5.23 grams of oxygen gas is allowed to completely react with the nitrogen monoxide? Again, I'm telling you that all of this is going to react. That, therefore, in this case, oxygen is the limiting reactant, and NO would be the excess reactant. Okay? Let's see on this example, one of the first examples that we did. Okay. 6.28 grams of lithium metal is placed into a large amount of water. Okay, I'm telling you, this is the one that's going to react all the way. The water is not. So the lithium is the limiting, and the H2O is the excess. Okay, and again, what did we use to figure out the products? The limiting reactant. Okay, let's come back up to here. Let's see if we can see any. Here they just say how many moles of HCl are needed to react with 0.128 moles of magnesium. So here they're wanting to know how much of this do we need. So again, in most cases, it's going to tell you how, which one is the limiting reactant and which one is the excess reactant. Many times it'll even say, it might say here, 6.28 grams of lithium metal is added to, and they might even put in the word excess water. Okay? So in that case, that they're telling you this is the excess reactant. So many of the problems that we do don't involve limiting reactants and excess reactants, but sometimes they do. Okay? Which means that when they do, the first thing that you have to do is you have to figure out which one is the limiting reactant. Okay? And again, it comes down to how the problem is worded. Okay, if it talks about one of the reactants being an excess, like 22.5 grams of CO2 reacts with excess H2O, then it's not a limiting reactant problem. You already know that the limiting reactant is carbon dioxide and the excess would be water. Okay, but how do you know if it is a limiting reactant problem? If a problem gives the mass of both reactants, then you have to figure out which reactant will run out first. Okay? For example, if they say 22.5 grams of CO2 reacts with 25 grams of water, see how they're giving you the mass of both of those reactants? And when they do that, you have to treat it a little bit differently. Okay? So the way that you're going to do that is, first of all, you have to have a balanced equation. Just like any stoichiometry problem, you have to have a balanced equation. And then here's what you're going to do. You're going to use stoichiometry and you're going to convert from the mass of one of the reactants. So you're going to take 22.5 grams of CO2 and you're going to convert that to grams of water. Okay, and how do you do that? You convert the grams to moles, you do stoichiometry using the balanced equation, and then you convert the moles of water to grams of water. Okay? And then you're going to get a number. Okay? And let's say that number is, let's say it's 15 grams. When I convert 22.5 grams of CO2 to 15 grams of water, what that is telling me is that I need 15 grams of water to react with all of that carbon dioxide. Okay, this is the real important part. Make sure you're paying attention here. Okay, so when you convert from one reactant, the mass of one reactant, to the mass of the other reactant, that's how much of that reactant you need to react. Well, remember up here, this is how much water you have. You have 25 grams of water. But down here it's saying you only need 15. And what does that mean? It means you have extra water. And that's telling you that water would be the excess reactant, because I only need 15 grams, but I have 25 grams. So if I only need 15, but I have 25, then I've got extra. I've got 10 grams extra that I'm not going to need. Okay? And if H2O is the excess reactant, then CO2 has to be the limiting reactant. Okay? Now, let's change this up a little bit. What if I convert grams of CO2 to grams of water and I get 40 grams of water? Again, that still means that I need 40 grams of water. But now I only have 25 grams of water. So I don't have enough water to react with all of that CO2. And in this case, it's telling me that since I need 40, but I only have 25, I don't have enough water, and water is going to run out first, and therefore water is the limiting reactant. Okay? So that's step number 2, is you use stoichiometry, you convert the grams of one reactant. Now, it doesn't matter which one you do. You either convert your 22.5 grams of CO2 to water, or you convert your 25 grams of water to CO2. In this case, it does not matter, but you have to just choose one reactant and convert to the grams of the other reactant. And then you have to do the how much do I need versus how much I have. That's step number 3. Compare how much of that reactant you have with how much of that reactant you need. This will tell you which of the two reactants is the limiting reactant and is going to run out first. Okay, and then whichever one isn't the limiting reactant, the other one must be the excess reactant. And then the real important part is we're doing all of this first part. All these first 4 steps are to figure out what the limiting reactant is. Because step number 5 is you then use the limiting reactant to find how much of the product is going to be made in this reaction. Okay, so number 1, we write a balanced equation. Number 2, we use stoichiometry and we convert from the mass of one reactant to the mass of the other reactant. And then we compare them. We use the need versus have to figure out which one's the limiting reactant, which one's the excess reactant. And then once we know what the limiting reactant is, we use the mass of the limiting reactant, either this or this, whichever one's the limiting reactant, to figure out how much product we're going to get.